Now we're going to practice working from radians to degrees and so forth. We've got theta is equal to 170 degrees. We want to figure that out in radians. We want to give its exact measure, and then we're going to give an approximation. So what I'd like to start with is if you think about the whole circle, and you know that there's 360 degrees in the whole circle, then that's equal to 2 pi radians. Now I'll write the word radian right now, but unlike degrees, there's no symbol for radians. So you know in grade 10 and 11, your math teacher would take off a half mark if you forgot the degree sign? Because technically what you were writing was an angle in radians. Whenever there's no symbol attached to it, it automatically means radians. So if you were labeling a triangle quickly and you want to label 30 degrees and you just wrote 30, you really wrote 30 radians. And if you think 6.28 is once around a circle, like 30 radians is like 5 times around a circle. That's a huge angle. That's like almost 1,500, 1,600 degrees, maybe even more. So it's important to realize that no symbol means radians. But I'll write radians right now. If we wanted to find out what 170 degrees was, can you see that it would be easy to take this idea and get 1 degree first by dividing both sides by 360? So we know that 1 degree is 2 pi over 180 radians. Sorry, 2 pi over 360. I started simplifying before I wrote it out. And the reason I like starting with this is because when we looked before, right, we have 1 degree is pi over 180, and 1 radian is 180 over pi. Those are very similar. They're so similar, can you imagine yourself if you were trying to memorize and mixing them up every once in a while? Where 1 radian is 180 over pi, and 1 degree is pi over 180, that would be easy to mix those up. And if you mix those up and answer your question, it's going to be totally off. So this is a nice way of starting so that you don't mix them up. So we know that 1 degree is 2 pi over 360, or pi over 180. If you wanted to find 170 degrees, does it make sense? You would multiply both sides by 170, and you'd get 170 pi over 180. The other nice thing about grade 12 math is in all your math courses above, you'd always have to simplify your fractions to lowest terms. In grade 12, they assume you know how to do that, so you can leave it unsimplified. So this would be fine to leave it like this. However, if you check the back of the book, often the answers in the back of the book are simplified, and this one's not hard to simplify, to 17 pi over 18. But it's nice to know that you don't have to do that. And if we enter this into our calculator to get an approximation to the nearest hundredth, it's 2.97 radians. So what that means, if we were visualizing it, if we had a circle with this as its radius, you would have to travel that distance once, twice, and almost a third time around for that's length. Does that look like 170 degrees? Seems reasonable. And that's the idea. We would travel the radius once, 2, another 0.97 of the way around. And that would be equivalent to 170 degrees. So sometimes we're going to change degrees to radians. Sometimes we're going to change radians to degrees. So I'm going to show you how to do this with this same idea. And then I'm going to show you a shortcut if your radians has pi in it. Okay? So we've got negative 12 pi over 11. We want to sketch what that looks like in standard position. So right now it might be hard to imagine what negative 12 pi over 11 looks like. So So maybe what we'll do is we'll first change it to degrees, and then think in degrees and sketch it. And then we'll talk about ways that we can use radians to sketch as well. So we're going to start by doing part 2. We're going to change negative 12 pi over 11 to degrees. Woo. Now, first of all, we're going to start off, well, we know that 2 pi radians is 360 degrees. So if we wanted to find out what 1 radian is, you'd have to divide both sides by 2 pi. So if you wanted to find out what negative 12 pi over 11 was, what would you have to do to both sides? Multiply by negative 12 pi over 11. So if I multiply this side by negative 12 pi over 11, that's easy because you're multiplying by 1. But if you're multiplying this side by negative 12 pi over 11, this is what you would get. And can you see that your pi's are going to cancel out? And when you multiply, well, 360 divided by 2 is 180. 180 times 12 is negative 2,160 divided by 11. If we divide that by 11, what do we get? Someone have their calculator handy. Negative negative 196. So now, if you were asked to draw negative 196 degrees, and we have to remember our degree sign as we go, could you do that? A negative angle. So now in part 2, well, angles start at the positive x-axis. A negative angle is going to go in this direction. How far am I going to go? What quadrant am I going to end in? In the second quadrant, right here. Because I'm going to have to go 180, and then 16 degrees more would be our reference angle in this case. Now, one thing that you're going to have helpful for thinking about doing this in radians, and eventually I would like you to be able to sketch negative 12 pi over 11. Actually, right away, I'd like you to be able to sketch negative 12 pi over 11 without having to convert it to degrees first. And it's not that bad. What you're going to think about is you're going to think about, well, if this is 0, all the way around once is 2 pi. Halfway around will be pi. Does that make sense? Now, when we look at negative 12 pi over 11, you know that you're going to go in the negative direction. So we already know we're going in this direction. Negative 12 over 11 as a fraction of pi, can you see that that's a little bit more than 1? And 1 pi in the negative direction would be here. And then we need to go 1/11th more around, because it's 12 over 11. If you imagine this top half split into 11 equal sections, does that seem somewhat reasonable? Maybe a little big? And this angle right here would be, oh, that's a bad 11 because there's too many ones there. Pi over 11. Can you see that? Little part would have to be pi over 11. Because this would be 11 pi over 11 up to there, because that's 1 pi. And we have to go 1 pi over 11 further. So we could sketch this even if we didn't change it to degrees first. Finally, part C. Given theta is 7, I was going to show you a shortcut before we get to part C. There's a shortcut for changing radians to degrees if there's a pi involved. Now, one thing I want you to notice in this step right here. Did you notice your pi's canceled out? And you always have 360 divided by 2, which is 180. Because if 2 pi radians is 360 degrees, then pi radians is 180 degrees. So as a shortcut, when you have negative 12 pi over 11, since you know pi radians is 180 degrees, you could just replace the pi with 180. And that would change it to degrees right away. So if I say to you, what is pi over 2 in degrees? If you do the shortcut, 180 divided by 2, 90 degrees. If I say, what is pi over 3 in degrees? $60 degrees. What is pi over 6 in degrees? 30 degrees. You see in the shortcut? We change the pi to 180 degrees and then divide. Try and think of another one that divides nicely. What's pi over 4 in degrees? 45 degrees. What about pi over 12? It's a harder one. In degrees. 45. Close. 15 degrees. Could you do pi over 6? Is 30? Does it make sense that pi over 12 is half of pi over 6? To get 15. Okay, now we can get to part C. I'm going to erase some of this stuff that we had before. Now we've got an angle in radians that doesn't have a pi in it, given that theta is 7.5 radians. Let's figure that out to the nearest tenth of a degree. Well, again, we can start out that 2 pi radians is equal to 360 degrees. So if we start with that, we can find out that 1 radian is 360 divided by 2 pi, or 180 over pi. What would I have to do to find 7.5? Multiply both sides by 7.5. 7.5 times 180. Is 1350. Degrees, degrees, degrees. So 7.5 radians is exactly 1,350 divided by pi if we want to figure out what that is approximately to the nearest tenth, 429.7. 429.7 degrees. So I'd like you to try some of these right now. 4, 5, and 7.